Well, it's that time again, 6 p.m. Sunday evening, and welcome to Steve's Place. Tonight we're going to have Nuno here, who has been doing a lot of work with vortex-based math, and he's going to be doing it with Karen, who's quite knowledgeable in vortex-based math. In fact, she wrote a book on it earlier this year. In the meantime, though, I want to remind everyone, don't forget to get signed up for a YouTube membership. It's $9.99 a month to be a member, and it gives you access to uh, tons of videos. Well over 1,000, almost 1,500, I think. But I'm writing more every day. Not every day, but every week. I'm adding about 5 or 6 or more, and pretty soon I'll have the 2023 videos all up there and everything. So do become an exclusive member, $9.99 a month. And then I want to remind everyone, we send out emails. Please don't mark us as spam, and add us to your safe senders list so you get notified of who's speaking every week. These days I'm getting kind of delayed on getting the emails out because I've been going through some health issues. In fact, I just had another operation this week on Wednesday, and I'm back alive again and moving forward here. This will soon be over as far as my health issues. In the meantime, please give us some grace in that. And if you haven't signed up for the 2024 Tesla conference, now's the time to do it. We're still getting 25% off for people who register. If you register 2 or more, at the same time, you get an extra 5%, so that'll be a 30% savings. Coupled with our room rates, we start at $82 a night, includes breakfast. If you stay at the hotel, it's quite the bargain. Normally, these rooms run for about $180 a night, so you're saving a huge amount. In fact, you're saving so much, it'll probably help offset the cost of transportation. And then also every night, I want to remind people, like when you register, it's just not lectures and that. We also have like the big social things in the evening where there's food to eat and people to meet and talk with. You just don't get this at other conferences. This is probably the most affordable conference you go. It's a great chance to meet. It's a time to shake off the issues with COVID and everything and get back to normal life here and get out and meet people and live again, quite frankly. It's like everyone put their life on hold here for the last 3 or 4 years, and now it's time to get moving, time to start researching again and getting the science on other things besides COVID. So what we want is to get people signed up for the conference as soon as possible. It helps us in a lot of ways. Number one, I got to come up with an estimate. And I also want to tell everyone to take and be sure to hit that like button at the bottom of the YouTube channel there, and let YouTube know that we had a good show. And by us doing that, we know which people to get back on here sometime. So in the meantime, without further ado, let me introduce Neto and Karen. And y'all know Karen. Karen, do you want to introduce Nuno for us? Neto?
You know what? I do. I was going to pull up his bio, but it disappeared. So I'm just going to wing it. And Neto, you fill in whatever you think is appropriate. I have met Neto through Marco Rodin. And I just want to make a correction. I did not write Marco's book. That I did not do. I was with Marco helping him facilitate getting his work into the mainstream in the sense so that most people could understand. So I was his typist, his curious buddy who just teased as much out as I possibly could. So just want to make that clarification. And Neto came through Marco, and Marco's not somebody who makes things and is an engineer, but Neto is. So Neto lives in Portugal. He's here in the United States right now, working, innovating with some people, bringing some of the technology to life. So he's somebody who taken the esoteric teachings of Marco Rodin and put them into practical applications. He's got some patents. He's an electrical engineer. And with that said, Neto, anything you want to add to that?
Well, no, that's part of the story.
You want to tell a bit more?
It's part of the story. That's how we. Well, I started was by watching this videos from Marco online. I didn't understand any of it back then, but somehow it was appealing to me because this person was so convinced of what he was saying. Not only that, he got the math behind it, which it was transmitted in a totally different language. It's not a different language. It's a diversion from math. It's one branch of math that he was finding somehow the scriptures and translating the scriptures to a mathematical language. And well, throughout the years, and I don't know, probably 2 years, 3 years from there, I start to get interested in electrical engineering because I already had a degree in agricultural engineering and a bunch of other stuff too. Not mentioning, all of them, but I start to see and to become interested in electricity because he was mimicking what nature was doing. Somehow it was a circuit. Somehow we were, an energy source involved. Of course, it will take a certain route to grow itself. So I was very interested in nature, very.
Neto, when you and I were talking a little bit before, there was the part that you described within the electrical part that spoke of the 3, 6, and 9. And when you look at a telephone wire, how information is transmitted and how it actually develops a field. Why don't you kind of go into the 3, 6, 9, which is the key part of Marco's work?
Yeah. Well, yeah. Going to that. This 3, 6, and 9, for example, in electrical engineering, it appears right about anywhere. So you think about batteries, for example. You have steps of 3-volt batteries, 6-volt batteries, 9, 12. There is a relationship between this ratio or these 3 numbers that, in my view, has a direct correlation to a technology. So in this case, it's related to energy or electrical energy, because there's other types, of course. And there is a correlation between these 3 numbers. Tesla said it. Marco, it's multiple persons, referring to this ratio, and appears to have a connection with technology. If it has with math, it has to be a technology behind it. So, and it was so compelling when Marco said, "Okay, this is going to here, to here, to here. This is the ratio. This is." Back then, I didn't have an idea. Well, needless to say that Mr. Marco, what he'd done, he laid down a complete. This is my perspective. A complete pathway to the perfect transformer. For example, I interpreted it that way. You can see it as the magnetic field modeling. Or magnetic field pathway modeling, and the code is here, and you can see everything basically on classic electrical physics or electrical engineering, or you can go to the branch of physics. You have Einstein talking about these things. So I don't know if people know what the Hopfian is or Opfian fields are. It's
You need
very
to
popular, very,
go
very
for it.
popular in physics, and it's appears to be exactly the same thing. What Marco is telling us. And the advantage out of this vortex-based mathematics is that you can model. Here you have the modeling of nature or magnetism, whatever you want to call it, because this appears also to be connected to the Fibonacci sequence. So again, we have all these ratios that we can direct connect to electrical engineering, for example.
You made it start because you've talked about all of those things, but they all have something in common, which we talked about before, which was the triangle, which is also how you said how electricity conducts itself and how it circulates. That which goes back to the Fibonacci, which also goes back to fractals, which goes back to the whole structure of nature. So can we start back with the triangle part, because that was really quite beautiful.
Oh yeah, that was good. So electricity is a triangle, basically. So again, we have a correlation here. You know, hydrogen or the water molecule, it's a triangle again. You know, appears to be the basis of this kind of geometries modeling. It gives you an idea that either this things goes in steps or ratios of 3, at least from what I've seen in electrical engineering. It's very common that we have a 3-phase motor, a 3-phase transmission line. You know, you can have 6 phases, you can have 9 phases, you can have there's multiple phases, but it will be on within this ratio, within this triangle formation, appears to be the best way to put a field together, or a magnetic field, or something that you know, even plants can use this ratio. Nature uses this ratio to harness, to be, you know, coupled with the other, this Earth magnetic field around us. So,
No, you talked about how.
Wait.
You talked about how on ones there's, when you see poles, there's 3 lines. There's one line that's red, one line that's blue, and one line that's center. But you also talked about, it was so cool, how the birds actually navigate knowing they see the color. They see
do.
They see. So explain that, because that actually goes back to Walter Russell's work in the polarity. It
do,
shows.
yeah. So we have multiple videos online. For example, Ken Wheeler demonstrates the ferrocell. The ferrocell is a very good instrument that we have nowadays to, you know, see a magnetic field, which is 2 optical glass, you know, circular kind of things, lenses or whatever. And you have this ferrofluid in the middle, and then you shine an LED on the sides. Then you put the magnet behind on top, and you will start to see the ferrofluid reacting to the field that is around the magnet. And since that was discovered, the ferrocell, I don't know if many people knows the implications of this, but it's the best instrument that we have to date to see how a magnetic field looks like, right? Because you can model it, you can predict it, you can do anything, but the actual physical object instrument to see it, at least in the crude way, it was mind-boggling to me, because I recognize this structure. So, and you can pull up one of our study that we have done. That will be good.
When some people can imagine it, when you see the thing, the magnetics moving, it actually almost looks like the flower of life. You can see the grid as he moves. Yeah. And you can see it.
It does this, right? It's something like this. Yeah, and as a direction.
And that also looks like 2 torus fields.
That's correct. Yeah. with the dielectric plane of inertia at the center. So we will have where magnetism departs, it's from the center, and it goes and twists and rotates as a rotation, as a direction.
And
right?
you said too, the other thing you said before was that imagine the Earth. So imagine you've got the top pole and the bottom
Correct.
pole. And you said that the North Pole actually had a red
shift.
A red shift in it, and the bottom of the Earth literally has a blue shift in it.
Yeah, you can see it on the ferrocell.
Yeah.
You can see it on a ferrocell. You don't have to have a magnetic field detector to tell you that's north or south. You see it by the colors. And the birds, yeah. And birds also have iron in their blood, and we have iron in our blood. So it acts, the high acts like these lenses that has this nano, it will be a ferrofluid of some kind because he has to react to a field. Only ferromagnetic materials will react to a magnetic field. So when the birds are really going to point A to point B, they're seeing this red shift and blue shift. That's how they know where it's north and south. That's, now you have a compass in your eyes. It's like a F-35. You always know where you are because you have your compass. All those things.
But as this thing fluids and moves, explain the magnetic field and how that's sort of how we experience it and how you use it in energy.
Well,
that's the Rodin coil concept, is it not? That's what we're talking about. We go back into that idea. We go back to the Rodin coil. That's
it. But yeah, it's in front of us now. You see when you put the magnet underneath it, it's doing this toroid thing. Yes, it's exactly what Marco has put on the numbers. For example, if you have one of the pages of your book that has this ratio number, that you have this beautiful colors, red, even any other three colors or the same colors around, you have blank spots and color spots. And for example, Marco's always told us, hey, you cannot put anything on this, part of the structure because that's where magnetism appears. The direct relationship is when you see it on a ferrocell, magnetism, it's just 1/3 of this thing. The other three parts it's a dielectric field. So we have a dielectricity and you have magnetism. You have these two things, right? One, it's counterspatial, and the other one is spatial, right? What you see on the ferrocell, it's these lines. I don't want to call it lines of force, but
I'm gonna go.
You will have this magnetic field that now is attached to this ferrofluid, and it's making, it's trying to, how can I say it? You can see in the lights that the lines are there in the screen. So you can only see the lines, but you cannot. You have the lines and the black behind it. It's the entire thing. Whatever you see black, it's a dielectric field. The lines are actually the magnetic field lines. So
I'm trying to find it as I'm sitting here looking through because the book's 300 pages.
On my presentation.
Would this be right here? This part where you can see the lines, the black, white, this?
That's correct. Yeah, so all you see, those things around, that's the field created by an activated, for example, transformer. If you can see it.
And I know these numbers, the 147, 258, 369, all add up 369, and there's the repeating and the recurring. So there's nothing, there's a fundamental principle that everything operates on. And it's like it started with in the beginning, it's 3, and then it compounds and doubles, and then it again. So it's
Yeah.
interesting. And they're nested systems. That's the other thing. And so as they move and interchange, they create different patterns and different grid things. It'd be much more like not Walter Russell, but Gerald Pollack's work, where you have a water system, a fluid system of a liquid firmament, where you see the different geometries happening within. So when you see all the numbers that Marco has within here, and as those numbers move, you create different things.
Correct. It's application dependable.
Yeah.
What do you want to do with it? Here's the ratio. For us,
yeah, go ahead. I'm sorry.
Yeah, so for us, it's just do things here. If you want to achieve a certain goal, here's the ratio. Here's where, if you want, I lost count how many versions of the transformer there are in the industry. It's 300 versions that you can put together, for example, a motor or a transformer.
So you've got something new that
there's different ratios, and what it struck me was that those ratios, and if you pull up the ratios for Marco, they aren't exactly the same thing. It's almost ridiculous.
You know what that reminds me of? You and I.
How this person was doing, something like this without probably not even knowing what were the applications were, just discovering a new mathematical language. What Marco did, it's no short than telling us, that's what you need to do to make it, an exhaustible, a very efficient transformer. Yeah, by his own words, it's an exhaustible propulsion system, which he claims it's the will work of nature. So, and Tesla said it. Humanity will be free when you get, or the technology that this humans produces attaches themselves to the will work of nature. So Marco is saying the same thing, that this is nature patterns, and this is the perfect modeling. It doesn't have any mistakes. So it should be a very, in my perspective, and I have correlated all these numbers with what I'm interested in building, which is a very efficient motor, a very efficient transformer, a very efficient transmission. I want to do better on my field, and this is exactly what I found. Is if you go and research it on Google, for example, you will have this funny thing. What if you type, what is the most efficient transformer on electrical engineering, for example? You type that out on Google. The first thing that will appear, it's a toroid. It's a toroid. We use it. It's a ferrite core. And the claims behind the electrical engineers are, okay, you can contain more your magnetic field because it is the shape of magnetic field. So it's a closed loop around the wire, right? As opposed to dielectric field is radial. And essentially, you will see 10 points why a toroidal transformer, it's a better way to transform electricity from AC to DC or step-down transformer, whatever. Not AC to DC, because the transformer doesn't do that. It's only a rectifier. But really, if you want a very efficient, for example, for medical grades, it's always a toroid. Why? Because it has the lowest hysteresis cycle imprinted into the material. It's ferrite. It's high pure ferrite, and you can see many advantage in there. Go and research it. Don't take my word for it. And the people that really are wanted to see if there is really a correlation. Is there a link between what this man is talking about and the electrical engineering? And it's countless. It's countless. I lost count the similarities, and probably it's not that well researched. And that's the route we wanted to go, partially on this company.
When you and I talked, I mean, I know Marco said he's seen your stuff and it does work. So he does acknowledge that. The other thing that when you and I were talking in the book that I helped Marco pull his stuff, his workout, one of the papers he has was on Bill Ramsey's. And you said when you did it, you basically verified some of the stuff from the early days. So here was the numbers. I think it was on this page right here that you were talking about.
Yes. So Bill Ramsey has done a pretty good analysis and study of the system itself. I think he was the first one to correlate Marco's math and electricity. And here's the proof, which he goes to different ratio and different bifilar coils or whatever was the experiment he has, now we have a chart to see what's the inductance, what was the number of turns, what was the ratio, the size of the thing that he was trying to build. Because it matters, size matters, volume and number of turns and the angles and blah, blah, blah. By making a transformer, it does matter, of course. And he was the one that, was telling a bunch of things and reporting and documenting, because us in the future, if we want to base our work, we need others' work. We need, people that wrote books or took notes. Otherwise, it's lost. And Bill Ramsey has done a beautiful job, and it was the baseline for example, for me now to cross. I have values of inductance. Now I can calculate and I can reproduce if his findings were. It's consistent from what I found. The only thing we can do to verify things, first, you have instruments and you have all this technology that will help you. And nowadays, I mean, we have developed such an incredible set of instruments that can tell us much more than 2 years, 3 years ago. And it's funny that you've shown that graphic over there.
Well, it is the way. I let the universe. I'll open that one up.
It's very funny. This. If you go to electrical engineering, that's a 3-phase transmission line. Thank you, sir. Thank you, sir.
Yes, Dr. Neto.
So it's really, really interesting. For example, on the top left-hand side, you will have exactly a 3-phase transmission line. It's exactly.
And there is the red, the green, and the neutral. And there you go.
No. Actually, this is L1, L2, and L3. It's just aught lines. There is no neutral on this system yet. Just a 3-phase transmitter. It's a 3-phase transformer. At this point in time, it's just an oscilloscope picture of a 3-phase sine line. So when things are on, other things are off, and there is a sequence to imprint on this circuit, right? If you want to do a motor, if you want to do a transformer, if you want to do anything, this is how you do it. You use instruments to see on your oscilloscope. So whatever Marco has came across, which is no other than, in my books, beautiful. Yeah.
Let me ask a question, because see, there's something that comes to mind when I think of your toroidal field. I'm a toroidal field. The Earth is a toroidal field. Our universe even is built within a toroidal field, and so it's energy systems within energy systems. And if well, I won't go there. But if the Earth is already a system, then there must be energy coming up that we can actually pull from the field or the Earth field. There's already energy within the field.
Yeah.
Isn't that something that Tesla kind of thought about? I mean, I'm just kind of thinking about that myself. So there must be energy within the Earth field. There's an energy within this field. And as Tesla said, it's all energy, and we can pull from the vacuum.
Yes. First of all, Tesla found that the Earth was the perfect. You can transmit energy through the Earth.
Mm-hmm.
Let me put it this way: the Earth, it's a very good transmission line. No wonder, because it's made out of metals, right? Materials.
Mm-hmm.
It's made out of crystals. I mean, we're talking about conductors, semiconductors, all of them pressured and stacked together. So it's no wonder that we have discovered back then how the hell this thing can work in our advantage from the telegrapher days. So there was a Earth battery. It's the only thing that they got back then. You got, again, Nathan Stubblefield on the top of a hill with lights, with the Earth battery itself. Everybody was looking at the top of the hill. How the hell this man has electricity and his house is completely illuminated, right? So the Earth is a big reservoir of magnetism, right? And he has a magnetic field, of course. So these people back then found a way to either transmit being powered by the Earth or use nature to their advantage to achieve a certain goal. And Tesla was doing just that too, of course. He was using the ionosphere as a positive, and you were using the Earth as a negative. So from a higher to a lower potential, we all know that our atmosphere is positive, and if you ground things, it's you're quote unquote neutral, but it's ground, which is minus. So immediately you see that this thing serves a current flow, right? So if there is a current flow, there is a magnetic field. It's that simple. And if you have the materials to transmit it, which the Earth has, you will do it from the magnetic side of things, right?
Yeah, because we're attached to the Earth and we're grounded, literally, and we are tapped in with the resonant field of the Schumann resonance. So how does all that and electricity kind of play into all that?
Well, electricity, it's an hybrid, right? It's volts and amps. He has a magnetic component, he has a dielectric component, and he has a ratio of existence, right? Apparently, it's 1:3. The exact ratio is 1 part magnetism and 3 parts dielectricity. That's what these things appear to be in relation of thereof. So, I forgot what your question was.
No, here's just how related, even how do we get energy from Earth? So it seems to me that there's always an exchange between the ether. We're affected when there's solar stuff. We're affected everything. Yeah. It's kind of funny. I took a picture where you could see your hair standing up with electricity.
Yeah.
So it's the same as the way the ferrofluid rises.
Yeah.
Exactly the same. And now when you said we have iron in our blood, I'm thinking, yeah, okay. Oh. And so it's like we even have a monitor when a hair stands up or a cat has his hair stands up. So, and I decided I finally should get to your presentation part here where you're talking about how the fields work. And again, there's the red and the blue and the center point where it's, yeah, you want it.
You can see at the side the classic representation of a magnetic field. So
Yeah.
what we were having, you know, the past that we had, it was something like this, right? Which is perfect because now he has a shape and he has arrows. So something, there is a vector to it. So that magnetic field, it's departing from somewhere and it's going somewhere else. Correct? That's beautiful.
Well, here's the other thing you and I talked about a little bit before, which is kind of interesting. If you think if we're living in this vast sea of water,
Yeah, we are.
Whatever, we're like these little eddies that kind of go in and out. We're like bubbles that pop up and then go back into the sea.
There's nothing physical to this field, so I'm not quite sure if that is the question, but
Leads you.
What?
Go where it leads you, because I know you can go somewhere with that.
Yeah. So nothing of these, it's physical, so it's a field, and a field, it's a ether perturbation. So it's a sort of vibration. So when you threw up the ether, it's like Tesla said, it was not, when he was firing his motors, he has this funny thing that it's not turning the motor on, but it's turning the heater on, right? Because nothing is, so this thing is being manifested, right? So
you know
we live in this field. We live in this field.
When you have a kid, you know, you don't think about anything. And for me, it wasn't until I had a kid. And then all of a sudden, you know, you're turning on the water on your stove. And right now, it's just a nothing. And all of a sudden, you turn on the heat. And all of a sudden, what does it do? It bubbles up. But it doesn't just bubble up. It right? It goes into an arena. It doesn't like stay. It actually creates like little continents in itself. Yeah. And then when it's done, it evaporates. It's kind of like the water cycle. And it also basically, to me, speaks to the eternal nature of life, where it's always in this recycling system, which goes back to your triangular. Here's your jet energy, and here's how it's forming. And it goes, and then it gives us information, but it's still doing this.
Yeah. Yeah. It actually is doing what is shown on the right side of the image.
Yeah. There you go.
If you draw a circle encompassing these two toroids, you will have on the green plane of inertia, that's your equator. It's where, quote unquote, stillness, where we don't have that much change. That's your, let's call it zero, right? It's where the atmosphere is longer, right? So it has the highest column of atmosphere. It's at that point, and it shrinks to the poles, right? It becomes lower and lower and lower as you approach the poles. And you can see that the green, it's the equator. You can see that blue, which is, it's north, right? Sometimes I forgot what this called. But yeah, and you have red as it could be upside down. Red should be north and blue it's south. Now you look at this, and what are the patterns that we can prove that this is true? If we go to weather patterns, you know that a low pressure on the north hemisphere is going counterclockwise. The low pressure is going counterclockwise. And as opposite in the south, the same low pressure has a different, it's an opposite direction. It's going clockwise. So both the same things are rotating at different directions in different places, right? Well, I've just described a magnetic field around the magnet. That's exactly it. In a magnet, you have a center point, which is the center of the magnet, which is where we have this dielectric plane of inertia. The dielectric plane of inertia, allegedly, it's where magnetism is coming from, because at the center of magnetism, there is no magnetism, right? You cannot measure it because it's coming from there. And what it does, the toroid that you see, it's the collapse of that effect.
Is that
right?
your 0 point?
And then it goes and collapses into itself again.
Okay.
So,
Is that Marco's 0 point?
correct. 0 point.
Okay. So the 0 point is where everything.
Zero is zero. There's
yeah.
nothing in there. Zero.
And then okay, so let me imagine this for them. So it's if you go to your 0 point, and as things bubble up in their numerical sequence and turn and twist. But here's the interesting thing that came to my mind. When I think of the red, there's your heat. When I think of the blue, it's where it's cooling. So it's coming in and going out. It's coming in and going out.
Correct.
Okay, but there's something more than that.
Like the weather patterns. You see the weather patterns?
Yeah.
They do just like this, right? And they are composed, of course, in the system above. You will have also high pressures and low pressures. You will now start to see the wave. If you pull up meteorology chart, just all the lines, the isobars, you see low pressure, very close lines together, because now I have something more close to each other, just like a magnet. If you want a stronger magnet, you will have a high magnetization ratio. And now you can see the lines of force are close together, right? On a ferrocell, you can see that. A weaker magnet produces a better geometry on the ferrocell than a strong magnet. It's something like this, but it depends on the ferrocell that you're using.
One more orderly and one more chaotic? I'm just curious. I don't know.
No, it's just show the same thing. It's just the same pattern, but it's a much more small geometry.
Okay.
Much more small, because what happens is the smaller the space, the higher the capacitance. So in electricity, that is true. The smaller the space, the higher the capacitance.
That goes back to Feynman's in a tiny little cup, or in a tiny drop of an ocean. Of the same sort of idea, is it right?
Yeah, correct.
Pack the more. It's like a little baby rattlesnake. It's got more potent than a big one, because it's okay. It's the same idea. And what the other thing it reminds me of, if you look at the picture over here, that we can actually make move, but it also reminds me, if you look at that and you place that over a river does this, and we always talk about it as currents, and we don't think of it, that's electrical. No, it's actually doing electrical. It's moving, it's jostulating, and so nature is mimicking this on so many different levels.
Oh yeah, it's the basic parameters of nature.
Yeah, you know what I was thinking is, you got your right brain and your left brain. You got one that does one component, one that does the other. One's creative and one's processing all the little numbers and codes. That's it. The dyslexic part of me didn't quite get that coding part, but there you go. So this is Steve. Are you there? I don't know. I don't see him. There we go. You want to make animate that picture. I think I have that one. Oh, no, I don't have that one. That's okay. But you know what? Go to the other magnetic one that we have that's moving. That's the black and white one.
Yeah.
Thank you. So
I'm sorry.
that's okay. You're good.
Something is falling.
So does
So
that,
what we are showing here, Karen,
now I'm asking Neto to kind of explain it. Neto, are you there or did we disappear you for a while?
I'm here. Yeah.
Okay, so we're showing your magnetism.
All right. Oh, that's, yeah. So in order for us to prove all these things, we need to at least have some baseline and see if these things are working as we think they're working. Or if you want to make a collage from different minds, you have to build the analog to see all these things. And then here I am with a flat disk magnet with I don't know what their discs are called, but they have you can go online, and what I've done is I printed this on a paper and match it to the size of the magnet and see if I got a correlation between where this ferrous rod that I got on the line will go to those lines, right? Or eventually, if I could probably put something on movement and excite this movement, that these things will follow a pattern, right?
Mm-hmm.
So what I found was, throwing the piece through the magnet randomly from every single angle, this thing will now spin. And if I approach the center of the magnet, this thing will accelerate towards the center of magnetism. And that proves, in my book, that ferromagnetic material that is attracted to magnetism has to go and mimic, or at least give me an idea of what this thing is. It circular? Is it goes in crosses? But no, once he catches the field, he wants immediately to rotate. Or is it attracted on, if I throw it any single angle, I just have to go to meet that field, and immediately it does a parabola to get into that sort of a field, right? It's like water going down the drain. So what we were trying to see, again, water going down the drain, has a certain pathway to get itself out of the way to perform a geometry to go to point A to point B with less resistance, right? That's what nature do. So this is why I was trying to see with this experiment is, okay, it's circular, it has this pattern, it has this deceleration, so I'm closer to the center of magnetism. Now I'm spinning faster, which means I will be in this acceleration dissipating all magnetism. And I reach to a point where there is no magnetism, and it's the dielectric plane of inertia, and now this thing's reversed. Somehow, at that plane, or that center point at zero, and it starts to rotate in the opposite direction. So something like this. Now, if I go down the drain with this will do the same movement. It looks like he's going on the other direction, but if you see it from the perspective of the center of this thing is rotating in the same direction. If you're looking on the other hand, it's rotating on the opposite direction. Is it perspective? Is it a movement? Is it something that we can measure? That's why I was trying to,
Here's a couple comments that actually go with what you're saying, and then Steve, take me back to my screen part. One is somebody's mentioning ley lines, and so when you look at that one picture, you do see ley lines, and ley lines do happen on the Earth, and
they do.
there's and the ancients, or where all the cathedrals and waterways were always aligned, as Freddie Silva said, with the cathedrals. They always had the elements underneath, and they always put them on sort of quadrant points, and that's Maria's comment. And again, we're all talking about spirals, and so yes. So here's the interesting part here. When we look at this, you can still see the flower of life, the magnetic field, sort of showing its structure. So that's just my 2 cents. So go for it.
Yeah, this is the ferrocell, and you can see it there already. In this case, I think we're with a circular magnet. That's why you see the toroid very tight on the middle. This was a very powerful magnet, so the lines, quote unquote, lines of force are closer together. So it has a high pressure field, or a high Gaussian field.
The other thing it's showing is, which is Marco's work, you can see the triangular or the diamond shapes.
Yes.
And they are at an angle.
Mm-hmm.
There's one part of his model where the old things, they'd always show it kind of like straight lines. And with him, like with your work, it's always angular because things are spinning like this. They're not spinning squares. Life is not spinning squares.
I'll put it this way. The tilt of the rotation of the Earth as an angle. And that angle is closely related to the preferred pathway of magnetism. So it has to be.
So here's where I think you're talking about. This is Ken Wheeler's work, is it not? And we're here. There's
work, correct, from Ken Wheeler's book, A Genius. It's like having Faraday, or even Tesla alive, and he wrote this beautiful book. I mean, I don't know if someone is reading them, but I mean, if you are a modern hero, electrical engineering, please go there. If you have some sort of an interest to know what these things are doing, or what are the shape of magnetism, is that a possibility for us to see anything? Because I'm sure 5 years from now, the ferrocell will be, I don't know, it will be a three-dimensional, monitor, just like we have improved so much in LED television and all of these things, and imaging, of course, on the medical side. Who knows that if someone will pursue this enough?
I think Ken's book is free online for people. It is. And the interesting part, he actually spoke at the Energy and Science Conference Technology in Spokane, probably about 4 years ago. And I met him. And he is so sort of very serious, but at that presentation, he was such a hoot. He has such an amazing sense of humor. You would have no idea. He riveted, and they went on extra because he was so fun and so funny. So that's actually a very interesting, if you're looking to buy a video from the ESTC site, Ken Wheeler is a really good one to do that. He's been in my magazine, Science to Sage, and he's quite the hoot. So,
An inspiration, such, he essentially is the model magnetism. Again, I can see all correlations between what is saying and what the ferrocell is saying and what Marco is saying. All of these people didn't met each other. Schauberger didn't met Marco. Heinz Hopp, the inventor of, or the guy that modeled the Opfian. And we got as recent as Joe Rogan, I think was Eric Weinstein, that went on Joe Rogan and he said, you know what the Hop vibration is? It's the most important thing there is to know, Joe. Hey, come on.
I think I need to look that one up, but I think I've had it in something, but I'll look that one up. Thank you.
And Weinstein showed the picture on the right that you see the Hop vibration, which again, you'll see, interesting. What is this? what are these people trying to model? The atom, a field, as it's physics? Can you call it really physicality? Has anyone took a picture of this besides the ferrocell? Because, you can see the effects of magnetism. Of course, the ferrocell, it gives you that, gives you the effects of a field being induced in the material. But, it appears to me to be the same thing. So this thing is rotating, has a vector again, and looks like these people are talking about the same thing. They're trying to model something that is of high significance.
Well, here's the other thing. It's got color in it. And the color part is electromagnetic. It's got color. So it's got the electromagnetic spectrum, which I looked at when we had not too long ago, but maybe 2 weeks ago, we had Steve Ross. And Steve Ross, even when you had a dis-ease, every dis-ease had a color. Mm-hmm. Everything bandwidth related to it. So when you look at this, you think, oh my goodness, everything has a bandwidth.
Now, if you tie this, this technology to Rife and to all those people that was doing back then, their work was suppressed. It's proven, right? I'm quite sure it's not a conspiracy at this point. Especially when you see what's going on in the world right now and in America with I don't want to go into politics, but you see all of these people making these crazy things just to be in power. They are willing to deceive you, willing to lie to you in the name of profit. And they misuse and miss a lot of things, misuse taxpayer dollars that goes to nowhere, goes to a place where you guys didn't pay it to be laundry on the other side. Excuse my, which is hard to me. It's hard to me to see as an engineer, I don't know if I'm a scientist or not. I don't think myself as one, but at one point, it's hard for us to get sometimes, financed or supported or, had some money to build new things and test new things, but it's not being used that way. So
here's what I'd like people to know about you. I've had the privilege of putting some things together for him just visually from whatever. He is absolutely an amazing, not only engineer, but when he does something, he does it beautifully. He does it where you just look at it and you have an incredible sense of awe. And underneath this, I've had the privilege of seeing all the itty bitties that you can't see, but I will tell you, it is worth noting the exceptional sense to detail and construct that he does in his detail. He is coming to the Tesla Tech Conference. He is going to do the demo and the presentation on Wednesday, I think at 2 o'clock, 2 to 4. And I really invite all of you. It's not that you come and get free food and you get free travel. There are 28 speakers in 4 days. And I will tell you that there is a symphony that actually bridges many of these principles together, because Steve Ross will be there talking about the Royal Rife and other things. And he's bringing original books. But Neto is bringing the technology that actually is a symphony and a dance that represents many of these things that go together in action. And I think these guys together are going to be a fascinating conversation. And I can't wait for it. But with that said, this one's a very funny one. Steve, can you put on the video for this? Because here's where you're going to some of this stuff is a bit dangerous.
1,100 watts. 220 volts. 230. 150 hertz. 700 watts, 230, 210 hertz, 223 hertz, 230, 680 watts.
Oops. Neto, you have a comment on that one? I think you could, Steve, just take it to Neto on that one.
Everyone loves this video. I'm glad Scott is okay. So, yeah, from what you have seen from the page previously, Scott is the author of all of my and his crazy ideas. He put together all the things that we do together. So kudos to him because he's put himself on the line to test all these things and to test all these principles. Scott is I don't. It's the most crafty and guy that I saw ever. He builds all our coils. Every single print and model that we have, it was him that put together. Winding by hand, hours, making it perfect. Putting in. We have to go there. So it takes a lot of by hand. And then this is the motor. You can go back, Karen, probably to the previous page, just to give a little bit of context here. So what people are seeing, it's on the left. We have a stator, which is an inductor array. Typically, we wanted to build a motor. That's what this is. This is the stator of a motor. So this is the coils that goes in between the two magnetic fields, or the two rotors, or the two magnet plates. So we need to have an inductor there to excite the field or the array, the magnetic array, and force him to rotate, right? That's how you build a motor. And on the left side, you will see a solenoid, which is just a wire in this way, a solenoid. Classic winding of a motor. In this particular array, we were doing an axial flux motor / generator, because also we wanted to test it as a generator. We're talking about the same things, doing different things at different points in time. Or, either you are moving something, or you can use it as a generator too, like a wind generator. So we're comparing that. So making the case of going for a solenoid and a toroid inductor by itself. So, and using the same grams of copper, using the same values of copper and area, surface area. So there is a volume to these coils. We can establish a comparison between something that is truly similar or very close in all parameters, but one changes geometry from. The only difference on this experiment is just geometry. The rest of the values, we try to put them exactly together. It's really hard to do, but it's a very, very close approximation. So we want to be as scientific as possible. So what we wanted to test, it was, of course, inductance, resistance, impedance, whatever you want to call, and all these electrical parameters that we need to gather in order to engineer something. Either it's from the power supply side, or from the motor side. So that's why we're using this comparison. So you can go probably to the next. Oh, the next was the video.
Yeah, you got it. Your
So,
slide deck is. But here's what I'm going to go back to a question or a comment that Maria had, and it had to do with something you and I had talked about before even the show. When we were talking about the field and the magnetic stuff, then it must be somewhat holographic. This is where you and I were talking about. There's that hologram. So out of that field of neutrons and protons that come together and create a field of energy, which is its own geometry, that is its own magnetic field emanating its own essence.
yes.
Yeah, and so
he propagates a magnetic field.
yeah, it's a propagation.
In
So
this case,
yeah.
in this case, we have different geometries, so we will produce a different effect, different field by itself. If we go and have a solenoid on the ferrocell and the toroid on the ferrocell, we will see that we on the toroid geometry will have a better approximation to what magnetism, what the final geometry of magnetism is, right? If you try, it's like it's mimicking. You are mimicking something to get something out of it. Either it's less resistance, either you use less energy to couple those lines of force together by geometry, which in everything that we do as human beings has precision and geometry. That's all. So, and looks like that this geometry or a toroid field inductor, it doesn't look like, because we had the data behind it and it performed way better, 17% better than the classic solar.
So there's this one. I know when you come to the conference, you're bringing something that has to do with a wellness machine, and I would assume that that's going to like evolve a field of energy which is optimal. But that's number one. But before I say that, I'm going to say, Maria, you did not pick up unconsciously. You already knew, and you knew that intuitively. So I'm going to give you credit for already knowing. Oh my God. Okay. So based on that one, I'm back to you, Neto. So tell us, you've got something, and then we'll wrap up the show because we're a little over time, but that's okay. But I know you're bringing something that has to do with the field.
So we try to apply we try to apply the same base principles and the same field geometry. We don't have any data already. We are on the infancy of documenting that part of our intentions, because we want to contribute. We know that an intense dielectric field, for example, around you at the given geometry will benefit you.
Okay.
We have seen that to be true, for example, in plants. When you go to electric culture, back in the days, there were no fertilizer, and electricity was that sort of, let's say, exciting the field in order to have better results out of something. And
I guess you're dealing with both positive and negative. So as we talked with Steve Ross, you're bringing maybe the balance back of the energies, which he actually said might potentially deal with bipolar energy and people who are bipolar and bringing them back to center. That's maybe an interesting idea, bridging different things. I would think at the conference that might bring some interesting conversations.
Yeah, definitely. We're trying to do that same thing in order to benefit the human being as we can. So,
balancing the fields. And I'm going to say one thing, Maria, you need to call Steve. He's looking for a call from you. So that's all I'm going to say for that. Please call Steve, Maria. And then anything else? Steve, do you want to say anything to wrap it up?
Well, I just want to remind people that we're going to have a conference coming up in August. Now's the time to sign up. We have a 25% discount at this time. If you bring an additional person, an extra 5% off. And like I say, with the number of speakers we have and the free food and everything and the high discounts, it's a bargain, you know. And yeah, and just listen to stuff on the video on that and watching the videos. It's nothing until you actually go there and see stuff and you can hold it in your own hands, you know, and you get a feel for it. And again, you know, I want to remind everyone to do try to sign up on our YouTube channel. We can use all the members we can get, and don't forget, if you're on YouTube, don't forget to give us a thumbs up there, so that you know, in the future.
And here's what I'm going to say, Steve, one other thing. We're doing our best to actually bring you people that are going to be at the conference and not necessarily speak completely to what they're doing, but to give you a flavor of who they are. There are 28 brilliant people who are awesome, and we're trying to introduce them to you, to invite you. One way or the other, you're getting information, whether you can afford it to come or not. But there's nothing like sitting with the Neto or sitting with Steve or sitting with, you know, Marco might show up, he's teasing. And so with that said, we just want to say, please come join us. The dinners are fun. We sit out underneath cabanas in the warm heat of the summer and in the evening, and you can grab yourself a glass of wine, and there's free food after about 8 o'clock. And Greg Braden's going to be there, of the futurist, John Jitwell Peterson, his stuff is fun. So come join us. Come sit with us. Come have a conversation. Come give us a little nudge, because that's what we love.
And with that, I'm going to call it a night, okay? And we'll see you all next week. And thank you for coming, Nito and Karen. Okay.
You're welcome.
Yeah.
My